Hello students, in this video we're going to be going into a little bit more depth with regards to regression analysis. And here we're given the Hyundai Elantra, it's a type of car, and a study was done to compare the speed X in miles per hour with the gas mileage Y in miles per hour. So what I want you to do is I want you to enter the data into your calculator, enter in the speeds in list 1, and enter in the miles per gallon that correspond to those speeds in list 2. You need to make sure that the speed corresponds with the miles per gallon. So for example, the speed of 20 corresponds to 25.5. So I want you to enter the data into your calculator into two lists. Take a picture of your calculator and include it on this assignment. And what we want to do is we first want to create a scatter plot for the data. Remember, the scatter plot is the first type of graph. When you go to second and y equals for your stat plots, make sure your x list corresponds to the speeds, so that would be list 1. And make sure your miles per gallon, your y list, corresponds to list 2. As far as mark goes, you can control what you want your points to look like. They're simply for aesthetics. So after you have the data entered into your calculator, create a scatter plot and take a picture of the scatter plot and include that with this assignment. So this is what your scatter plot should look like when you create that on your calculator. And what we need to do is we need to complete, in letter B, a linear model. We need to do a linear regression. We need to find the line of best fit that corresponds to these points. So remember the way we do regression analysis. What we're going to be doing is we're going to be going to stat, moving the cursor over to calculate, and then we want to go to option 4 for linear regression. When you select option 4, this is what your calculator should look like. You want to make sure that your X list and your Y list match the X list and Y list that you used for the scatter plot. And here's the key. You want to move the cursor down next to store regression equation. So this fourth spot. You want to press alpha and then trace, and then this menu should pop up, and then press enter. So while the cursor is next to store regression equation, you want to press alpha, trace, and then since Y1 is highlighted, press enter. Now you should have Y1 next to store regression equation, and now you want to go down to where it says calculate and press enter. And on your screen should be 4 pieces of information. An A, a B, an R squared, and an R. Sometimes your calculator will omit giving you the R squared and the R. If R squared and R are not given to you on your calculator, what you want to do is you want to press the mode button, scroll all the way down to where you see stat diagnostics. And what you want to always do when you do regression analysis is make sure your stat diagnostics are on. So if you needed to rerun that, turn stat diagnostics on and then rerun the entire process, the linear regression, aligning the screen, the alpha trace, the Y1, and then press enter. And then this is what you want to have on your calculator, and take a picture of this and include this in the assignment. You're given an A, a B, an R squared, and an R. A represents the slope of the line of best fit. B represents the y-intercept. Your calculator gives you an R squared and an R value. The R represents the correlation coefficient. It represents how strong of a correlation, how strong of a relationship do these two pieces of data represent. In this case, the speed of the car and the miles per gallon. Press graph on your calculator and you should see the scatter plot accompanied by the line of best fit. take a picture of this scatter plot with the line of best fit. Now, if you look at your data and all of your points, this line doesn't really represent those points well at all. The points increase and then decrease, and drawing a line with a positive slope doesn't really represent what's going on with those points. This R value tells you the strength of your relationship. Here our R is 0.35, and anytime your R is between 0.25 and 0.5, it's considered to be, in statistics, a weak correlation. So this line of best fit, if you had to describe how good of a job does it do to explain the association we have going on here, we would say there's a weak association. If you look at your points, though, there definitely is a pattern. The points in general increase. They kind of dip a little bit here, but then continue to increase. And then they reach a high point and then decrease. This general pattern is what we call a parabola. And that pattern, that parabolic pattern, is described in math as a quadratic equation. When you graph quadratic equations, equations that have x squareds, you get a parabola. So what I want to now show you is how we are going to create a quadratic regression for the data. I want you to go back on your calculator to Stat and then over to Calculate. But now I want you to select option 5, which represents a quadratic regression. So when you choose option 5, Stat, move the cursor over once to the right for Calculate and down to option 5 for quadratic regression, the same type of screen pops up as when you did a linear regression, except now it says quadratic regression. Once again, I want your X list to be L1, your Y list to be L2. I want you to move the cursor now down to where it says Store Regression Equation. And while the cursor is next to Store Regression Equation, once again what I want you to do is I want you to press Alpha, the green button, and then Trace. But now what we're going to do is this. I want you to move the cursor down to option 2 for Y2. Here I took a picture of my Y equals screen, and if you notice, the Y equals screen has the line of best fit from the linear regression stored into Y1. What I want to do is I want my calculator to find a quadratic equation that fits the data, and I want the calculator to save the quadratic equation into Y2 of this graphing screen. So after you press Alpha Trace, choose option 2 for Y2. Now that Y2 is saved next to Store Regression Equation, move the cursor down to Calculate and press Enter. And this is what your screen of the calculator should look like. Take a picture of this. And you notice it looks a little bit different than the linear regression does, because what we're trying to do is we're trying to come up with a quadratic equation, a parabola that best fits our points. Now, if you think back to your experience with the quadratic formula, A always represented the number in front of the x squared, the coefficient of x squared. B represented the coefficient of x, the number in front of the x, and C represented the number by itself, the constant. So if you notice, A, B, and C are given to you for a quadratic equation. Now these particular values are not whole numbers, they're decimals, because what your calculator is doing is trying to find a quadratic equation that best fits those points from the data that you entered back in the beginning of this problem. Your calculator gives you the r squared, but you notice the r is not given to you. And the reason why is that it just doesn't fit on the screen. So what we're going to do is we're going to take the square root of r squared, to get our R value, to get the correlation coefficient, to see how strong of a correlation exists between this quadratic equation and the data. Here's what we need to do to get R on our calculator. First, press second and then x squared on your calculator. So that should give you your radical symbol. Now the key is you want to take the square root of what R squared was to get R. And what you're going to do is you have to follow these steps immediately following a quadratic regression. So that's what we did. We just ran a quadratic regression. What you're going to do after you press second and then x squared to get the radical symbol, you're going to press the vars button, the variables button on your calculator. Choose option 5 for statistics. Move the cursor to the right twice for equation, and then go down to option 9 for R squared. Now, when you follow these steps in this order, what's going to happen is on the main screen of your calculator, it should look like this. You're telling your calculator to take the square root of the last R squared value that you calculated. And if you follow those 5 steps in that order, second and then x squared for the square root, pressing the vars button, going down to option 5 for statistics, moving the cursor twice to the right for equation, and then going to option 9 for R squared, when you have this on your calculator, press enter. Your calculator gives you R, which is the correlation coefficient of the quadratic regression. And if you notice, the R value is 0.98. And if you know the categories that I talked about before, anytime your R value is in between 0.75 and 1, this is 0.98, so it's almost 1. 1 would be a perfect positive correlation. Well, here 0.98 tells us the quadratic regression is strong. The association between the parabola of best fit and the data is very, very strong. And what you should now do is this. You should press graph, and you should include a picture of your scatter plot with the 2 models drawn. And include this picture with the assignment. Here you see your data, you see your line of best fit, your linear regression model, and then you see your parabola, your quadratic equation of best fit. And because the quadratic's R value is close to 1, you can clearly see that this parabola really does represent the point very, very well. This quadratic equation represents a very strong correlation between the speed of a Hyundai Elantra and the miles per gallon that the car achieves. So this is how you perform a quadratic regression on your calculator. And it's raining.